This video is going to cover simplifying radicals, including how to find square root of negative numbers, which will introduce the concept of I, or imaginary numbers, and then solving some equations that involve using I. The first thing that we want to talk about is knowing perfect squares. So you ought to be familiar with all of the perfect squares. And so what I want you to do right now is, in this space, make a list of the first 15 perfect squares. In other words, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, and so forth. And go all the way up to the number 15. Okay, these are numbers which you should be working on memorizing. Is there ever going to be a test where you have to know exactly what they are? No, but it is really to your benefit if you can memorize all of these. These are numbers that will show up on tests in this class. They will show up on ACT tests. They will show up on SAT. And if you know these, it's going to make everything much quicker and easier for you. So it's helpful for you if you do memorize them. Part of the reason I want you to memorize those is that we're going to talk about simplifying radicals. And when we simplify radicals, we use perfect squares. So different teachers teach this differently. And I know that your calculator can do a lot of this for you, but I need to show you kind of what the concepts are, what the basics are behind it, so that when we get to more difficult problems, you will understand the basics. To simplify a radical the way I do it, I look for the perfect square that goes into 75. So I think of my list of perfect squares, and I look at that list and I think of, okay, which one of those would go into 75 evenly? And so if I know my perfect squares, it's pretty easy, and it comes to me pretty quickly that that's 25. Well, 25 times what? Well, 25 times 3. And so I can rewrite 75 as 25 times 3. And so if it's the square root of 75, I rewrite it as the square root of 25 times 3. Or in other words, the square root of 25 times the square root of 3. And so that's how square root multiplication works. And so going backwards, you can do it the same way. Okay, I chose 25 because it is a perfect square, and the square root of 25 is 5. So again, I know your calculator can do this, but I need to make sure that you know how to do it with the basics so that when we get to more difficult problems, you know what we're doing. That being said, I don't think we need to go through every single example, so I'm going to skip forward to number 3, which is asking about the number 24. So I think of my list of perfect squares, and actually on this one, and you always want to find the biggest perfect square that will go in, but in this case, the biggest one that will go in is 4, and 4 goes in 6 times. The square root of 4 is 2, and so my answer is 2 root 6. The next problem, 27, is a little bit different just because of the numbers that come out. So let's go ahead and take a look at it. The square root of 27, if I look at my list, the perfect square that goes in is 9 times 3. So I want to take the square root of 9 times the square root of 3, and that simplifies down to 3 root 3. Now the reason I'm saying this is a little bit different is some people get confused at this point because they're both the same number, but you can't do anything with those. You can't multiply them, you can't simplify them, you can't do anything. That's just the final answer. All right, next example has a number, the 3 out front. It's a coefficient. So what we need to do is we just basically need to keep that 3 there for a second. And we look to see what number goes into 48. Well, the problem with 48 is that there's a couple of them. So if we start at the lower numbers, we can see that 4 goes into 48. But we have to keep working our way up and seeing if there's a bigger number. And there is a bigger number. 16 also goes into 48. And so when we do this, we always want to pick the largest perfect square that we can. That being said, some teachers tell you to start with the bigger numbers and work your way down so that you always get the biggest one. Okay, so the square root of 16 is 4, so I have a 3 here, I have a 4 here, and then I have a root 3. And so my answer is 12 radical 3, because 3 times 4 is 12, and so that goes there. When you do these, the outside numbers, the coefficients, they can be multiplied together, and the I'm going to call them the inside numbers, the radicands, they can also be multiplied together, but you can't multiply inside numbers with outside numbers. Number 6 throws some people off, and the reason it does maybe is because it's so easy. I don't know. But 5 we have to keep here. Square root of 16 is just 4. There's not really any simplifying to do. It's just 4. And so this answer is just 20. We've already talked about some fractions, so you already know how to do number 8. Let's take a look, okay? On number 9, the thing to do here is split it up between the square root of 32 over the square root of 9. And so we know that the square root of 9 is 3. That's easy. And then on the numerator, 32 breaks down to 16 times 2. And so that answer is 4 radical 2 over 3. And that's as far as it can go. Number 10, there's a couple things you can do. I'm gonna do it one way, you might do it a slightly different way. I'm going to break down my 50, because 50 is 25 times 2. And 98 is 49 times 2. And so those root 2's, they can cancel each other out. And you can cancel them out here. Or maybe if you saw that originally, you could kind of cancel them out before you even started, and you'd get a 25 over 49. Okay, but now each of those, coincidentally, is a perfect square, and so that's just 5 over 7. Number 11 is similar, so why don't you take a second to see what you can do on number 11. All right, once again, a couple different ways you could do it, but you should come up with 11 over 3 root 2. My writing's kind of messy over here. This says radical 9 times radical 2, because 9 times 2 is 18. On the top, 121 is a perfect square, so I just have to simplify that. The last thing we need to do here on number 11 is we have a square root 2 in the denominator, and we cannot have a radical in the denominator, so we have to multiply that. So on our numerator, we have 11 radical 2, and on the denominator, we have 3 times radical 2 times radical 2. Well, that's like 3 times 2, which is 6. And so the final answer on that one is 11 radical 2 over 6.